Hello, grade 8. How are you today? I hope you all are safe and well. We studied about magnets, properties of magnets, and we said iron, cobalt, steel, and nickel are magnetic materials. We also mentioned that the only thing that magnet can repel and attract is another magnet, but magnetic materials can attract only, but they do not repel. Also, we talked about the domains. We said each magnet is made up of lots of very small regions called domains. So each domain react as a small magnet. When they are magnetized, they will line up in the same direction, and if they are demagnetized, they will point to different directions. And also we said we can make a permanent magnet by magnetizing a magnetic material. Today we will talk about the magnetic field. So what is this magnetic field? The magnetic field, we mentioned earlier about the force of a magnet. We cannot see it, but we can see the effect of the force of the magnetic force. So around a bar magnet, there is a field that experience a magnetic force. So open your books on page 138 and follow me. Magnetic fields. Ferrofluid is a special magnetic fluid that makes beautiful patterns when it's near a magnet. But why does it move? So here, this is a fluid, as you can see. It's called ferrofluid, which is made of consists iron. So this fluid is moving. As you can see, it's pointing up. So why does it move? When this fluid is magnetized, it makes a beautiful pattern or near a magnet. So what is this magnetic field? If you put a steel pin near a magnet, the pin will move. The magnet attracts the pin because it's exerting force on it. So here, if you put a needle or a pin, steel pin, like in horizontal way, and you came with a magnet like this, the pin will move up. Okay, it will move up. Why? Because the magnet here is attracting the pin to it. So it's exerting a force on it, which is the magnetic force. The region around the magnet where magnetic field materials experience a force is called magnetic field. So around the magnets there is a field that the material experience a force there. This is called magnetic field. The ferrofluid moves because it's in a magnetic field. So any magnetic material that comes near to a magnet will experience a force, which is the magnetic field, which it will enter the magnetic field, so the magnet will attract it. Seeing magnetic field patterns with iron filing. So how can we see a magnetic field? We can put something in the magnetic field that experience the force to show us the shape of the field. So here we have iron filing, which is like a powder of the iron. Okay, we can sprinkle this iron filing around a magnet, or we can sprinkle it slowly or gently on the magnet. In this way, it will experience a force, or it will be in a magnetic field, and it will take the shape as you can see here, and you can see in this way, you can see the effect of the magnetic field or the magnet. Iron filings are very small pieces of iron that become magnetized when they are in a magnetic field, because we said earlier that iron is a magnetic material. So these small pieces, they can be magnetized when they if they are near to a magnetic field, or if they in a magnetic field. They line up just like nails or paper clips, and there are so many of them that they can show us the shape of the magnetic field. We cannot see the magnetic field, only the effect of the magnetic field on magnets or magnetic materials. So we can only see a pattern here, but we cannot see the force itself. We can see the effect of this force on any magnetic material. You can investigate the magnetic field pattern around two magnets. So here we have two magnets, North Pole against the North Pole, and here South Pole against the North Pole. We mentioned earlier that like poles repel and unlike poles attract. So these two magnets are repelling each other. How did we know this? Because there is an empty area here, and the magnetic field is going this way, and here like this, and here like this. And in this way, in this picture, these two magnets are attracting each other. How did we know this? Because here they are attracting here in this point, and they are going to different directions. Point X is called the neutral point. At this point, the magnetic fields of the two magnets cancel out, like this here. They are repelling, so they are canceling each other out. So we call it neutral point. So we saw now the magnetic field patterns with iron filing. So what about a plotting compass? How can we see with a plotting compass? This is a plotting compass. So we are using it for directions, to show the directions. So we can use it to show a patterns or the magnetic field patterns. So we can take this compass and just follow the directions that it's pointing to. If you suspend a magnet on a piece of cotton, the magnet will line up in the same direction each time. This direction is north-south. A compass points north because its needle is a small magnet. It rotates and lines up with the Earth's magnetic field. I mentioned in magnet property or properties of magnet last time that the North Pole always lies or attracted to the Earth's magnetic field, the Earth's North Pole, and the South Pole of a magnet always lines up with the Earth's South Pole, or attracted to the Earth's South Pole. So if you hold a compass anywhere on Earth, always this compass or this magnetic needle will attract it to the North Pole of the Earth and the South to the South. A plotting compass is a very small compass. If you put it near a bar magnet, its needle will line up with the magnetic field of the magnet. Rather than Earth's magnetic field, you can use a plotting compass to see the shape of the field around the magnet. So how can we do this? We need to have a bar magnet like this, and we need to plot the compass in this way. So we need to draw a dot where the North Pole is pointing. Then move the compass like this and draw another dot. So each time we will do this until we can get a pattern. So then we can just connect the dots. Then we need to move the compass a little bit away. In this case, we will just follow the North Pole, or the north direction. So we are drawing a dot here, now a dot here, now another dot here, another dot there, and here. So see, they are making a beautiful pattern from the North Pole to the South Pole. Okay, and here from the North Pole to the South Pole all the time. We can show the pattern around a bar magnet more simply by drawing a magnetic field lines to show where the plotting compass lined up. The lines show us the general shape of the field. So here, as you can see these arrows, they can show us the field around the bar magnet. So the spacing of the lines indicates the strength of the field. So here the spacing, this space and this space and this space. As more as you are getting closer to the bar magnet, the magnetic field is getting stronger. When you are getting away from it, the magnetic field is getting weaker. So the field is stronger where lines are closer together. The arrows on the lines show the direction of the force. Magnetic field lines go from the North Pole to the South Pole. The arrows could have pointed towards the North Pole, but scientists decided that they will always point toward the South Pole. So when they start to draw these magnetic fields lines, they saw that the North Pole, the magnetic field always going from the North Pole to the South Pole. Magnetic field lines are just a representation of the field. There is a field all around the magnet, and the magnetic material placed between the lines would still experience a force. So if we put any material here, or any material there, or any material here or there, it will still experience the magnetism or the magnetic force. So the magnet will still attract it. Although we only usually draw the magnetic field on a flat piece of paper, the field exists above and below the magnet as well. So it's not just both sides, no, even up and down of below or above the magnet, up and down, we can find the magnetic field, or the magnetic field is exerting, the magnet is exerting force, or any material could experience a force around the magnet in any direction. So what about the Earth's magnetic field? We studied in the previous lesson about the magnetic materials, and we said that we can find them in the Earth's core. So we said these can create a magnetic field around the Earth. So what is this magnetic field? The Earths behave as if there is a huge bar magnet inside it. Of course, there is nothing called a bar magnet inside the Earth, but it acts like there is a magnet inside it, because it pulls or attracts the magnet to its poles. So the magnetic field pattern is like that of a bar magnet, but there is no bar magnet inside the Earth, and we are not exactly sure how its magnetic field is produced. If a compass needle points north, then the South Pole of the Earth's magnet must be in the north. So How is this? Because here the compass, it's always points to the North Pole of the Earth, not the North Pole, the geographic one where is like Antarctica or something. No. It will line to the North Pole of the Earth only. So maybe the South Pole will be in the north of the Earth. Compass needles actually point to the Earth's magnetic North Pole, so not the Earth's geographic North Pole, not the Antarctica. So which is at the top of the Earth's axis. The magnetic North Pole is in Canada, about 1,200 kilometers away from the geographic North Pole. So the magnetic North Pole of the Earth is in Canada, and it's away from the geographic North Pole of the Earth. So it's not the same as North Pole or Antarctica of the Earth. Now I'm going to leave you with this video to show you how can you draw a pattern, or how to draw a pattern or to see the magnetic field around a magnet.
It's probably safe to say that you have a very good idea of how the magnetic field of a bar magnet looks like. But do you know the 4 important properties of magnetic field lines? To find out, let's begin by plotting some magnetic field lines. You need a pen, plotting compass, and a magnet. My magnet doesn't tell me which is the North Pole and which is the South, but we'll find out soon. Place your magnet in the middle of the page and trace around it. Place the plotting compass near the magnet. Mark the direction that the compass needle points by drawing a dot. After the first plot, move the compass so that the back of the needle lines up with the dot. Repeat this until you reach the end of the magnet. Join the points together to show a field line. I'll also draw an arrow here to show the direction that the needle is pointing in. I'll do all of the above again with another starting point. Looking at the field that we've plotted, we can figure out the 4 main properties of magnetic field lines. Number 1, magnetic field lines never cross each other, they never overlap. Number 2, they always point from the North Pole of magnets to its South Pole. North into South, so that must mean that this is North and this is South. Number 3, they're continuous. The only reason these lines have been cropped out here is because I've simply run out of space. Number 4, where the lines are closer together, the magnetic force is the strongest. That's at the poles of the magnets.
So after the video that you saw, let's go to the summary of the lesson. Magnetic fields. A region where magnetic materials experience a force is called a magnetic field. You can find the shape of a magnetic field using iron fillings or plotting compass. And we said the plotting compass is a very small compass that used to find directions. The Earth behaves as it has a bar magnet inside it, but of course it doesn't, but it acts like this because it attracts the North Pole of the magnet to its North Pole. So here I drew a simple diagram to show you the North Pole and the South Pole of the magnets. So here the arrows points to going from the North Pole to the South Pole, from the North Pole to the South Pole. This is called the magnetic field. I hope you understood the lesson. This was about magnetic fields. And if you have any question, write it down. Don't forget to write these notes in your notebooks. And see you next time in a new lesson. Bye bye.